Installing a 600 amp 120/208 three-phase service can involve several cost factors. Based on the provided information, the total cost could range from $5,000 to $8,000. This estimate includes both materials and labor. Let's break down the material costs. A main service panel with a 600 amp fuse disconnect can cost approximately $2,000. Two main panels might each cost around $1,500, totaling $3,000. The sub-panel, rated at 225 amps, could be approximately $500. Circuit breakers might range from $500 to $1,000. Wiring materials could add another $500 to $1,000 to the material costs. Now let's consider labor. An electrical contractor might spend between 40 and 60 hours in the project, and the hourly rate could range from $60 to $80 per hour. This brings us to discussing lower cost options. Various manufacturers offer alternatives to QOBVH equipment. Siemens Type SD panel boards are known for their durability and reliability at a lower price point. GE-THUP panel boards offer a wide range of features and are backed by a strong warranty. Eaton CH panel boards provide a cost-effective solution for residential and light commercial applications. Here are some tips for reducing costs. Firstly, consider purchasing materials yourself and hiring a licensed electrician for the installation. Secondly, obtain multiple quotes from different electrical contractors. Thirdly, explore grant or incentive programs offered by your local utility or government agencies. Fourthly, negotiate with contractors on the labor costs. There are additional considerations to keep in mind. The provided quote may not include necessary permits, inspections, or other fees. The actual cost may vary depending on factors such as location, availability of contractors, and the complexity of the installation. When evaluating panel boards, it's important to consider several factors beyond just the initial cost. These factors can significantly impact the overall value and long-term expenses associated with the electrical system. Firstly, consider the panel board's compliance with industry standards and certification. Panel boards should be listed by a nationally recognized testing laboratory such as Underwriters Laboratories to ensure they meet safety and performance requirements. Secondly, think about the panel board's interrupting rating. This rating indicates the maximum short-circuit current that the panel board can safely interrupt. Select a panel board with an interrupting rating that meets or exceeds the available fault current at the installation location. Thirdly, consider the panel board's design and construction. Look for features such as a sturdy enclosure, ample wiring space, and clear labeling. These features can simplify installation and maintenance. Fourthly, think about the panel board's expandability. Choose a panel board with enough spare spaces to accommodate future circuit additions. Fifthly, consider the panel board's ease of maintenance. Look for features such as removable branch breakers and accessible wiring terminals. These features can simplify troubleshooting and repairs. When selecting circuit breakers, there are several key characteristics to consider. Firstly, the amperage rating, which must match the circuit's requirements. Secondly, the interrupting capacity, which needs to meet or exceed the system's fault current. Thirdly, the trip curve, which defines how quickly the breaker trips under overload or short circuit conditions. Fourthly, the type of breaker needed, such as standard, grand fault circuit interrupter or arc fault circuit interrupter. Wiring materials also play a critical role in the overall cost and performance of the electrical service. Firstly, conductor material. You'll typically choose between copper and aluminum conductors. Copper offers better conductivity and corrosion resistance, but is more expensive. Aluminum is lighter and less expensive, but requires careful installation to prevent oxidation and loosening of connections. Secondly, conductor size, which must be properly sized to handle the expected current load. Use appropriate ampacity tables and derating factors to determine the correct conductor size for each circuit. Thirdly, insulation type, which must be suitable for the application and environmental conditions. Common insulation types include THHN, THWN, and XHHW. Fourthly, conduit type, which provides physical protection for the conductors. Common conduit types include rigid metal conduit, electrical metallic tubing, and flexible metal conduit. Selecting an electrical contractor is a crucial step in the installation process. Firstly, verify the contractor's license and insurance. Ensure that the contractor is properly licensed to perform electrical work in your jurisdiction and that they carry adequate liability insurance and workers' compensation insurance. Secondly, check the contractor's experience and reputation. Ask for references from previous clients and review online reviews to assess the contractor's track record. Thirdly, obtain multiple bids. Get bids from several contractors to compare pricing and services. Be sure to compare the bids apples to apples, considering factors such as materials, labor, and warranty. Fourthly, review the contract carefully. Before signing a contract, read it carefully to understand the scope of work, payment terms, and dispute resolution procedures. Permits and inspections are essential parts of the electrical installation process. Firstly, obtain the necessary permits. Before starting any electrical work, obtain the required permits from your local building department. This ensures that the installation meets safety codes and regulations. Secondly, schedule inspections. After the installation is complete, schedule an inspection with the building department to verify that the work was performed according to code. Thirdly, address any deficiencies. If the inspector identifies any deficiencies, correct them promptly to obtain final approval. When negotiating with contractors, it's helpful to have a clear understanding of the project scope and your budget. Firstly, be prepared to negotiate. Don't be afraid to negotiate with contractors to get the best possible price. Secondly, focus on value, not just price. Consider the contractor's experience, reputation, and the quality of their work when evaluating bids. Thirdly, get everything in writing. Make sure all agreements are in writing, including the scope of work, payment terms, and warranty. Utility and government incentives can help offset the cost of electrical upgrades. Firstly, check with your local utility. Many utilities offer rebates or incentives for energy-efficient equipment and upgrades. Secondly, explore government programs. Check with your state and local government agencies for grant or loan programs that may be available. Thirdly, take advantage of tax credits. Some energy-efficient upgrades may qualify for federal tax credits. Exploring the possibility of purchasing materials yourself can sometimes reduce costs, but it also introduces some additional responsibilities. Firstly, research and source materials carefully. Ensure you are purchasing the correct materials that meet all applicable standards and codes. Secondly, understand the warranty implications. Purchasing materials yourself may affect the warranty coverage, as the contractor may not be responsible for defects in materials they did not supply. Thirdly, consider storage and handling. You'll need to provide secure storage for the materials and ensure they are handled properly to prevent damage or loss. When comparing different panel board manufacturers, several factors can differentiate their products beyond just price. Firstly, the busbar material, which is typically copper or aluminum. Copper busbars offer better conductivity and corrosion resistance, but are more expensive. Aluminum busbars are lighter and less expensive, but may require more careful maintenance. Secondly, the branch breaker compatibility. Ensure that the panel board is compatible with the type of branch breakers you intend to use. Some panel boards may only be compatible with specific brands or series of breakers. Thirdly, the enclosure type. The enclosure must be suitable for the environment in which the panel board will be installed. Options include NEMA 1 for indoor use, NEMA 3R for outdoor use with rain protection, and NEMA 4 or 4X for wet or corrosive environments. When considering Siemens panel boards, it's helpful to know some of their key features and benefits. Firstly, their rugged construction. Siemens panel boards are known for their durable construction and reliable performance. Secondly, their versatile design. Siemens offers a wide range of panel board configurations to meet different application requirements. Thirdly, their advanced features. Some Siemens panel boards include advanced features such as arc flash mitigation and energy monitoring capabilities. For GE panel boards, consider these aspects. Firstly, their wide range of options. GE offers a comprehensive selection of panel boards to suit various needs. Secondly, their strong warranty. GE panel boards are backed by a strong warranty, providing peace of mind. Thirdly, their innovative technology. GE is known for its innovative panel board technology, such as their quick trip breakers. Eaton CH panel boards are another option to consider. Firstly, their cost-effectiveness. Eaton CH panel boards provide a cost-effective solution for residential and light commercial applications. Secondly, their ease of installation. Eaton CH panel boards are designed for easy installation and maintenance. Thirdly, their robust design. Eaton CH panel boards are built to withstand harsh environments. When installing a 600 amp service, there are some critical safety considerations to keep in mind. Firstly, working with high voltage electricity is inherently dangerous. Only qualified and licensed electricians should perform this work. Secondly, always de-energize equipment before working on it. Verify that the power is off using a voltage tester before touching any electrical components. Thirdly, use proper personal protective equipment. Wear appropriate PPE such as safety glasses, gloves, and insulated tools. Fourthly, follow all applicable codes and regulations. Ensure that the installation complies with the National Electrical Code and all local codes. Fifthly, double-check all connections. Make sure all connections are tight and secure to prevent overheating and arcing. Finally, test the installation thoroughly. After the installation is complete, test all circuits to ensure they are working properly. Remember, the information provided is a general guide. The actual costs and requirements for your specific installation may vary. Always consult with a qualified electrical contractor to get accurate estimates and ensure a safe and code-compliant installation. Consider all these factors to ensure you get the best value and performance from your electrical service upgrade.